Hello friends, myself Balaji. Today I am going to discuss about the current to voltage converter. Before going to the current to voltage converter, let us talk about the basic concepts of the and definitions of the current and voltage. What is voltage? Voltage, it is the potential difference in charge between the 2 points in an electric field. And what is the current? You will all know that the flow of electric charge is also called as current. The SI unit of the current is amperes. And the current to voltage converter, it has one application. It is an opamp. Opamp, it is a DC coupled high gain electronic voltage amplifier with a differential input and usually a single ended input. So let us move to the next slide, that is the current to voltage conversion. Let us say one sensor or the circuit component which gives the output terms of the current. As the sensor gives the output to the current, we have taken a sensor as a photodiode. You will know that the next example. You have a photodiode which gives the output in terms of the current. Then you want to log the data of this photodiode for the entire day. Let us assume that for the you are using the data acquisition system. Now most of the time this type of system uses to accept the data in terms of the voltage, so that you need to convert this current into this voltage, and for this I to V converter are used for the voltage converter are useful. For the data acquisition you need a voltage, then there is a current in output for the sensor, you need a input for the data equation is the voltage, then we will use the IV converter to convert the current to the voltage. Let us say you want to log the data of the photodiode for the entire day. Let us assume that for that you are using the data acquisition system. This type of system which uses to accept the data in terms of voltage, you need to convert the current to the voltage. For this I to V current to voltage converter is also example of the current control and the voltage source. Now we have learned about the current to voltage conversion, why we use the IV converter. Now we will see the internal working of the IV converter. Let us go to the next slide. There the IV converter, you all know that the current is the input and the voltage is the output. Where the input current is the current source is the symbol of the input current, it will be like that in the internal part of the IV converter, and the voltage source is same as where the plus and minus, where the positive and negative charges will flow in the voltage, it will be in the output of the voltage. Before going to the next slide, the voltage converter is same as the passive converter. It is a work like a passive converter. When the resistor is connected to the current flowing through a wire, it will look like a passive converter, where the V is the output of the resistance. In this case we can convert the current into the voltage, and we can take the voltage from this, it will look like a IV converter for us. In the expression is V is equal to IN into R. As the same way they have connected load resistance to the parallel to the resistance R in for the same current input. There where the V1 is the voltage across the RL. The voltage across the RL is given by the IN is equal to IN multiplied into RP. RP means is the combinational circuit of the RL and R. RL into R by RL plus R. Where the I1 where it is a parallel connection, where the I divides into I1 and IL. I1 flows through R and IL flows through RL. If RL is greater than R, there will be variation in these two figures. The V will be more and the V1 will be less. To avoid these conditions, we must use active current to voltage converter. We must go to the next slide. It is the current to voltage converter diagram. A current to voltage converter will produce a voltage proportional to the given current. This circuit is required if your measuring instrument is capable only for the measuring the voltage. Only the voltage can be measured from this opamp of this circuit. You need to measure the current output. If your instrument or data acquisition module has the input impedance that is in several devices larger than the conventional resistor, a simple resistor can be used to do conversion. There will be errors in the small resistor, there will be large resistor. You must use the small resistors to reduce the errors. If the input impedance of your instrument is low compared to the converting resistor, then the following op-amp circuit should be used. This circuit should be used for the current to voltage converter as the active current. Let us go to the next slide. Active current to the voltage converter, where the input current is connected to the inverting terminal of the op-amp, where the minus is the negative is the inverting terminal and the positive is the non-inverting terminal, where the positive non-inverting terminal is connected to the ground and the inverting terminal is connected to the input current, where the resistance is connected to the V out and the non-inverting inverting terminal. First, for the ideal op-amp, we must keep the zero voltage where the current no current flows in the op-amp. IR is the current passing through resistance. IN is equal to IR. We apply KCL on it. 0 minus V naught. Where is V is equal to IR formula we have applied. V naught is equal to IN into R minus IN into R. Sorry. V naught is directly proportional to IN. Here the indicates that V naught is directly proportional to the active current to voltage converter works here. As the same application of the voltage current to voltage converter, trans impedance amplifier is used. It is also same and the load resistance is connected to the resistance, where it doesn't dependent on the load resistance. Here the load resistance depend on the voltage, but in passive the load resistance depend on the voltage. As load resistance changes, voltage also changes, output voltage. In the active current to voltage converter, there is no change in the voltage. When the input is connected, when the KCL is worked, there will be no involvement of the RL is involved in the V out. We can see the input is the Z is equal to V by I. V out is the output and the IN is the input, where the Z is equal to output by input, V out by IN, where V naught is equal to Z into IN, where the V naught is directly proportional to IN, that is active current to voltage converter. This type of amplifier is called as trans impedance amplifier. It is the application of one of the current to voltage converter application. Let us go to the next slide, that is using photodiode, our application of current to voltage converter using photodiodes. In the photodiodes, this op-amp is used in the photodiode. There's in an inverting terminal, the photodiode is connected to the N junction, and in P junction is connected to the ground, where 0 is greater in the P, it will work. When this light rays falls on the photodiode, current passes through the wire it depends on the intensity of the light. Whether the 0 volt virtual ground, non inverting terminal of the op-amp is also 0, as the current flowing through the op-amp is also 0. When the current flowing through the resistance is IR and the current flowing through the photodiode is I phase, IPS. That means when we apply the KCL rule on this A to B on the line A, IPH is equal to IR, where IR is equal to V naught by R. IPH is equal to V naught by R. V naught is equal to IPH into R, where the V naught is directly proportional to the I phase. It indicates that it is directly proportional. Active current to voltage converter. It has successfully converted into voltage. Now going to the next slide, that applications of current to voltage converter. Digital to analog converter, where the digital signals are converted into analog signals by using the current to voltage converter. Sensing current through photodetector, such as photocell, photodiodes, photovoltaic cell. You have learned these photocells, photodiodes and photovoltaic cell in the first sem of the engineering and second PUC. Photoconductive device produces current that is proportional to an incident energy or light. It can be used to detect the light. It is the Einstein theory, E is equal to h nu formula, which is applied at the photodiode. These are the applications of current to voltage converter. Thank you.